Hey everybody, this is Mr. McKee with Net225. Today I'm going to be going over Packet Tracer 9.3.3, which is HSRP configuration guide. Alright, I do have up my Packet Tracer workspace and I've got it zoomed in pretty good so you guys can see it really easy. I like doing that. So first thing, let's look. We have PCA connected to S1 on a LAN 1, and then PCB connected to S3 on LAN 2. From there we have two routers. We're just going to assume that these are our HSRP router pair. And then from there, R2 is our edge router going out to the internet. And then somewhere out there on cyberspace on the other end of the planet, we have a web server. All right. So if we look at our addressing table on our activity window, we have R1, all right, 3 interfaces, all right. And what you want to notice too, when you start looking at your IP addresses, remember router to router configurations, they're going to be a CIDR of 30 normally, all right, because two possible host interfaces, broadcast, and a network address. All right, so 4 total. So \30, 255.255.255.252. You don't waste any IP addresses doing that way. All right, so one right there, that's probably router to router. This one's probably router to router. You can look down through here and verify that, but you got a bunch of those. You know, it looks like a lot of these are on the 10.1.1. something network on the outside on our WAN networks, and our internal networks and our LANs. Let's see, R1 is 192.168.1.1, so that's probably on the 192.168.1.0 network. All right, that's pretty normal. Router 2, you see right here, it changes from a 10 to a 10.100.100, so that's probably our exit out to the out to our ISP, which that is correct. All right, looking down here, R3, which is connected to LAN 2, LAN IPs, LAN IPs. All right, that's internet. That means on this side. Internet just means it's probably connected to an ISP. Well, it is connected to an ISP, unless we're an ISP ourselves. All right, it goes out there to the internet. All right, so S1, it's got a SVI, VLAN 1 right there. Has a default gateway assigned. S3. Right, PCA, PCB, that's pretty standard. Different default gateways. All right, web server out there. Now, one thing though, and you just have to kind of like imagine it. All right, R1 and R3 are going to be our HSRP pair of routers. So if one goes down, the other one can stay up. So our HSRP virtual gateway is this IP address, but just imagine that sitting in the center. All right, I know in the on Netacad, it kind of like has like a little virtual router sitting in there. So just understand that it's sitting in there, and what it's doing it's comprised of these two routers sending hello messages in between the two to figure out, you know, who's the active router, who's the backup router, things like that. All right, so just imagine that. If I was to make this topology myself, I'd put it in there and just note it. All right, so let's keep going. All right, and just a note right here, the iNet router is present in the internet cloud. It cannot be accessed in this activity. That's fine. All right, in this packet tracer activity, you will learn how to configure hot standby router protocol. All right, to provide redundant default gateway devices to host on LANs. After configuring HSRP, you will test the configuration to verify the hosts are able to use the redundant default gateway if the current gateway device becomes unavailable. All right, so when configure the HSRP active router, HSRP standby router, and then verify HSRP operation, more than likely taking down one of those routers. The active router and seeing if the standby router comes up online. All right. A spanning tree protocol provides loop-free redundancy between switches within a LAN. However, it does not provide redundant default gateways for end-user devices within the network if a gateway router fails. First hop redundancy protocols, or FHRPs, provide redundant default gateways for end devices with no additional end-user configuration necessary. By using the FHRP, two or more routers can share the same virtual IP address and MAC address and can act as a single virtual router. Hosts on the network are configured with a shared IP address as their default gateway. In this packet tracer activity, you will configure Cisco's hot standby router protocol, which is an FHRP. You will configure HSRP on routers R1 and R3, which serve as the default gateways for the hosts on LAN 1 and LAN 2. When you configure HSRP, I don't know why it's hard for me to say that, you will create a virtual gateway that uses the same default gateway address. That's a big thing you gotta realize. We're not setting up like a backup, like an active and a backup default gateway address, because that's not going to work for us. We're setting up a virtual router with one default gateway, and then two routers share that virtual router IP address. All right, one is forwarding packets, and then if that one goes down, the backup comes online and starts sending packets. But to all your hosts inside your LANs, they don't realize something's changed. All right, so just understand that. All right, where to go? Let's see. Blah, blah, blah. If one gateway router becomes available, the second router will take over using the same default gateway address that is used by the first router. Because the hosts on the LANs are configured with the IP address of the virtual gateway as the default gateway, the host will regain connectivity to remote networks after HSRP activates the remaining router. All right, and that's what they're talking about when you look at your addressing table. HSRP virtual gateway 254. All right, is the fourth octet, and right now that's the default gateways. The your two LANs you're looking at. All right, 1.1, which is router 1. Up here, gateway gigabit 01, and then 1.3, which is right here, router 3. So right now, PCA is going there, and then PCB is going here. All right. So, all right, trace the path to the web server from PCA. Go to desktop or PCA and open the command prompt. So we're going to be doing a trace route. All right, and what we're doing is we're trace routing all the way to the web server. All right, we could trace route closer, but we're going to do what they tell us to do. All right, trace RT 209.165.200.226. All right. So if you look up here, where are we at? We're first going to 192.168.1.1, which is that. That's our first hop. Second hop, 10.112 is router 2. Or I'm sorry, 192, yeah, that's right. 192.168.1.1 should be router 1. Yep. So router 1's our first hop. 2 is our second hop. 10, 100, 102 is our third hop. I'm just assuming that's our, say, our ISP for like CenturyLink or whoever, layer 3 maybe. And then finally it gets to this router or to this web server, right? So 4 hops. And what I'm going to do too, just to be sure I don't have to retype that, I'm going to copy that from PCA. All right, so which devices are on the path from PCA to the web server? Use the addressing table to determine the device names. I just did that. I didn't even look at what it wanted, but I just did that. All right, so trace the path from the web server to PCB. All right, so we've copied it. We don't have to type it in again. Saving a little bit of time. Going to command prompt, right-click in, paste, trace route, same web server. This should change from PCA, and I can already tell 192.168.1.3 is router 3. And if you can swing it, I mean it's best case scenario, but when you start, you do this in real life, when you put your default gateways in, if you can use, a lot of times you can't really do it, but if you put the numbers, like the 192.168.1.3, that corresponds to router 3. 192.168.1.1 corresponds to router 1. That helps people out when they're looking at it. And when you're looking at it too, because you'll forget if you have a big network what's going on. All right, so we're going through PCB to router 3, which is that first hop. Second hop, 10.112, router 2 right there on gigabit 00, 10, 100, 102 is our iNets. All right, and finally out to our web server. All right. So we repeated the process we did first. Which devices are on the path from PCB to the web server? Those 4. And notice also, I've never seen 30 hops, but this will time out after 30 hops. All right. So observe the network behavior when router 3 becomes unavailable. Select the delete tool from the packet tracer toolbar and delete the link between R3 and S3. So I'm going to close that down, R3 and S3. So this right here. Let me scroll up just a smidge. All right. So delete's right there. Looks like a rewind button. Yeah, that's great. All right, so get my crosshairs, click that, and then you still have those crosshairs when you delete it, but press escape and it goes away so you don't mess anything else up. All right. Over the command prompt of PCB, execute the traceroute command on the web server as the destination. Compare the current output with the output command from step 2. Let's see what happens. So the first attempt timed out. Second attempt timed out. All right, we'll let it keep going. Probably like 4 attempts because we know something's up. And you notice too, everything still has green triangles, so everything's like converged, but that doesn't really mean a lot for us if we're not getting connectivity up to the internet. All right, so I'm gonna do control. I'm gonna click on the PCB terminal window and control C to break out of that. All right, you can hit fast forward. See if anything changes. Nothing's really changed. All right. So what we know now, we're not able to get out anywhere. All right, to the internet. All right. Click the connections icon in the lower left corner of the packet tracer window. Locate and select the copper straight through icon in the palette of connection types. So that's our lightning bolt. If you mouse over it, it tells us its connections. All right. Copper straight through. If you mouse over any one of these different cables, it's the solid black line. All right. Click on S3 and just make sure you click the correct port. So click on S3 gigabit 02, which is that one right there at the bottom. Click that one. Click R3. Select the port. Gigabit Ethernet 00. All right. It doesn't converge immediately. But if we did fast forward, all right, it's converged. All right, after all the link lights on the connection are both green, test the connection by pinging the web server. This ping should be successful. Well, we'll see, won't we? All right, so if we do up arrow for our history in our terminal, let's wait and see what happens. And I'm gonna pause this video just, well, it did it so fast, I don't have to pause it. All right, so we're back in business. Let's see, everything's the same as it was originally. All right, so where are we at? All right, so configure HSRP active and standby routers. Configure HSRP on router 1. So this kind of tells us our commands. All right, so click on R1. All right, notice that we're getting a lot of log messages. All right. And this doesn't specifically tell you, but just make sure you know what line you're on. Like this is showing us the global config. We're on the user exec mode, so we've got to get to global. So let's do enable configure terminal. All right, so interface, and I'm going to short that to int gigabit 01. All right. I like to just make sure you know where you're at. We're on configure interface. All right, specify the HSRP protocol version number. The most recent version is version 2. Note standby version 1 only supports IP version 4 addressing. That would be a good test question. All right. Standby version, whoops. Standby version 2. All right. Configure the IP address of the virtual default gateway. Remember that. This address must be configured on any host that require the services of the default gateway. It replaces the physical interface address of the router that has been previously configured on the hosts. All right. So remember also, we're going to have to change the default gateway on our hosts. Well, I say that if they're statically assigned IP addresses, yes. If not, we'd have to change our configurations in our DHCP. But anyways, we'll continue on. Multiple instances of HSRP can be configured on a router. You must specify the HSRP group number to identify the virtual interface between routers in the HSRP group. This number must be consistent between the routers and the group. The group number for this configuration is 1. All right, so standby group 1. That's what 1's telling us. IP, that's our virtual default gateway IP address, 192.168.1.254. All right, I can see HSRP 6 state change gigabit 01 group 1 status initialized. All right. So we haven't set priority yet. But now you know that on the first, I know it says that in the instructions or the chapter. See how it went from standby, it did a speak, and it found out, okay, nobody else is on the network that has HSRP. All right, it went from standby to active because since it's the only HSRP router on the network, it assumed the active role. All right, it didn't really say that in these instructions, but all right. So designate the active router for the HSRP group. It is the router that will be used as the default gateway device unless it fails or the path to it becomes inactive or unusable. Specify the priority for the router interface. The default value is 100. A higher value will determine which router is the active router. All right. If the priorities of the router in the HSRP group are the same, then the router with the highest configured IP address will become the active router. All right, so if you don't specify this, leave the defaults as 100 for both your HSRP pair. It's the one with the highest IP address will be the active router. But that's not good. That's not good practice. All right, so standby 1, group 1 priority is 150. All right, so now definitely we have the highest priority. All right, R1 will operate as the active router, and traffic from the two LANs will use it as the default gateway. If it is desirable that the active router resume the role when it becomes available again, configure it to preempt the service of the standby router. The active router will take over the gateway role when it becomes operable again. And you'd want to do that, like say if you have a standby router, your active router goes down, your standby router comes online, it's sending packets for you. You can go through there and actually do whatever you need to do to get that router back up, and then you can plug the original one back in, and it'll assume the role once again when it comes online. All right. So we got priority 50. All right, so standby 1 preempt. So this is going to be our active router, and also if it goes offline, comes back online, it's going to take over the active role once again. We hope. All right, and that's to know too. Like if you're messing with two routers that your power just went down, like our power just went down here last weekend, so I had to come in and do some stuff. That makes it easier to troubleshoot also, because you know what router is gonna become active once again. All right. So, what will the HSRP priority of R3 be when it is added to the HSRP group 1? And I assume they're saying what's the default priority, unless it's specified it somewhere up here, because we're working on R1 right now. But default's 100, so unless we specify something different, which doesn't look like it did that. And it's saying, let's see, configure HSRP on R3, configure R3 as a standby router, configure the R3 interface that is connected to LAN 2. All right. And remember that also you want to configure this interface. All right, not just any interface, because it's not going to work. All right. So let's go ahead and get over here. Router 3. We look at our log messages. Let's go enable configure terminal. All right, now we're good. Now, configure the R3 interface that is connected to LAN 2. This is LAN 2, R3 interface I can mouse over it. All right, it's going to be gigabit 00. So make sure you do that correctly. All right. So interface gigabit 00. Whoops. See, I just I haven't had enough coffee, obviously. Let's exit out of that. Let's do interface gigabit 00. All right, now we're good. Verify it again, gigabit 00. Okay, we're good. All right, we want to do standby version 2. All right. Standby 1, because this is group 1, IP address for the virtual default gateway 192.168.1.254. All right, it's initializing. All right, and it says repeat steps. Repeat steps B and C only. All right, and you can see it initialized it on group 1. State speak. It's like, hey, you know, who else on the network is doing HSRP? It was set to standby. All right, because of its priority. All right, so we're good there. And I haven't been looking at my completion rate, but we're at 60. All right, so step 3, verify HSRP configuration. Verify HSRP by issuing the show standby command on R1 and R3. Verify the values of HSRP role, group, virtual IP address of the gateway, preemption, and priority. Note that HSRP also identifies the active and standby router IP addresses for the group. All right. So let's actually do N to get back to our privileged exec mode. And I like making sure these are on the right side. All right, so I got R1 on the left side. R3 is hiding back here. All right, so let's tile those side by side. Let's end that. All right, so show standby on R1, show standby. All right, so gigabit 01, group 1 version 2. All right, state is active. And if you guys can hear that, I'm getting a bunch of alerts from my Ring doorbell. So the dog's probably running around. All right, hopefully that's what's happening. All right, so let's see. We got a version 2 running, state is active, 6 state changes, last state change 34 minutes. Virtual IP address right there is our default gateway, virtual address. Active virtual MAC address is right there. Our local virtual MAC address is there. All right, hello time 3 seconds, hold time 10 seconds. Next hello sent in 1.3 seconds. Preemption enabled. Right, active router is local. That tells you, okay, I'm the active router. So you can look at state active. You can look at active router's local. Standby router is this guy. All right, priority is this guy. Group name is HSRP gigabit 01-1. And that's like the default name. All right. That didn't really mean a whole lot. You'd probably want to change that name. All right. So gigabit 00 group 1 version 2 on R3. State is standby. So this one's on standby. 5 state changes, last state change, 40. I'm assuming that's 40 seconds ago. All right. Virtual IP address. Notice 254 and 254 are the same, right? Active virtual MAC address is there. All right, these are the same. Local virtual MAC address, those are the same. Hello time 3 seconds. Preemption is disabled. Active router. All right, standby router is local. All right, so 2 ways to say it's on standby. All right, priority is 100, default is 100. All right. So higher priority, R1 has a higher priority. So if it went down, well, it's going to be the active by default. But say you power these both at the same time, R1 is the active router. R3 goes down, R1 comes back up. It has, where is it at? Preemption's enabled. It's automatically going to take control. All right, it's taking control 2 ways. If it goes down, R3 accepts the active role, and then it goes back to R1. And if they're powered up at the same time, R1 is still going to be active. And don't think too much into that, just understand what's going on. But if they had the same priority, if these, you don't want to do that anyways, but same priority, it's going to pick whatever has the highest IP address, which that would get kind of confusing because in this case, if we didn't have preemption on, the highest priority is going to come from the R, in this case, our standby router, which is R3. So that gets confusing. So make sure you use preempt and then specify your active, your standby, and change your priorities to a higher priority for your active router. All right. So that's working, and I assume we're going to take down an interface and see if it works. All right, so using the output shown above, which these 2 outputs answer the following questions: which router is the active router? Well, you can look at those and tell what is the MAC address for the virtual IP address, what is the IP address in priority of the standby router. R3s are standby. All right. So use this show standby brief command on R1 and R2 to view the HSRP status summary. So let's go to R1, show standby. All right. So we're using the brief command, but there's a lot less information than just the full command. All this is showing is, in this case, R1 active is local, standby is this other guy over here on the right. My priority is this, my group's that. The local interface, this is the virtual IP address right there. Let's go to R3 and type show standby brief. All right. And you can tell right here, see on R1, it tells you, hey, another host is my standby pair over here. Standby is actually a local. Active, it's showing that it's over here. R3 is on standby. This matches this. Your group matches your group over here. Notice how these interfaces, R1's gigabit 01. All right, and let's look back here. Gigabit 01 and R3's gigabit 00. All right, so make sure you enter the correct interface. All right. let's see, change the default gateway address for PC1, PC2, S1, S3. Which address should you use? And then verify the new settings. Issue the ping command for both PCA and PCC to the web server. Are the pings successful? So go back to PCA, go to desktop right here. We got static IP address. All right, our gateway is going to change from 192.168.1.1 to 192.168.1.254. All right, with that change, and it just wants us to ping 209.165.200.226. Alright, so we're getting pings. Alright, and I'm going to go ahead and just copy that. I'm going to do these in order. Alright, PCA, PC. Oh, that says PCC, but it means PCB. Has some typos in there. Alright, 254. You notice this default gateway was different than PCA. Alright. Actually, I'm going to go over here and do paste. Alright, S1. Currently, let's look at this. Enable, should run. There's our default gateway right now. Alright. Alright. So if we do, let's see, config T. IP default gateway, and yep. Try to save too much time. 192.168.2. Whoop, I'm typing in my local. Alright, 192.168.1.254. Alright, that's good. If we do and show run, see how that's changed to 254. And I could just go ahead and copy that and go to S3, enable configure terminal, and if I do paste, alright, bang, it's done. Alright. And if you want to go from, if you want to go all the way from, well, actually, let's do exit. If you're like in an interface inside of the global config and you want to go all the way back to privilege exec, you do N versus exit. Right? N takes you all the way back just to save a step. Not really relevant what we're doing right now, but alright. So our default gateway now is 192.168.1.254. Alright. Now is the fun part. Now let's see if this thing actually works. Alright, so open up the command prompt on PCB and enter the trace route command. Alright, PCB. And I'm going to do up arrow. does the path differ from the path used before HSRP is configured? No. All right. Router 3. Router 3. I'm sorry, yes it does. PCB 1.1. Because now it's going from here up to router 1. Because you see right here, 192.168.1.1, 192.168.1.1 is router 1 instead of router 3. And then it's going from there. From there, it's the same. All right. Let's see. Yes. All right, so we were, let's see. Does the path differ? Yes. Break the link to R1. Let me see where we were at. All right. Select the delete tool from Packet Tracer toolbar and delete the cable that connects R1 to S1. All right, R1 to S1, delete tool right there. Delete that. Hit escape. All right, immediately return to PCB and execute the same thing, trace route. All right, let's try it again. Let's go to timeout. All right, there it goes. All right, so you see now it did do the original path. All right. Observe the output of the command until the command completes execution. You may need to repeat the trace to see the full path. We did have to redo it because we timed out on our second hop. All right. How is the trace different from the previous trace? Well, you can look at that. Here's our trace, and here's our trace here. I'll just bypass that one and I'll request timeout. All right. HSRP undergoes a process to determine which router should take over when the active router becomes available. This process takes time. Once the process is complete, the R3 standby router becomes active and is used as the default gateway for hosts on LAN 1 and LAN 2. All right, reconnect R1 to S1 with the copper straight through cable. I don't know why my instructions keep jumping up like that, but it's annoying. All right, so R1 to S1, let's make sure we do that correctly. I'm gonna click that, I'm gonna do the up arrow. All right. So gigabit 01. All right. I believe it's gigabits for 2. All right. All right, so we are all the way down here. All right, so execute a trace from PCB to the root service. This may need to be to repeat the trace to see the full path. reconnect R1 to S1. Okay. Right, let's do the trace route. All right, see how it changed? That was the previous, going through the standby router, and now it's going back to the original router. All right, what path is used to reach the web server? Path right there. If the preempt command was not configured on the HSRP group on R1, would the results have been the same? Well, you got to think about that. If we didn't have preempt, all right, and this is our active router, this is cut, this turns into our active router. If it didn't have preempt to come back up, this is going to stay as a as standby. It's not going to come back up. It's not, preempt means bring me back as soon as I get back on the network. Put me back in as the role of active. All right, and that's it. I know this video went a little long, but I like to explain, especially a lot of these protocols that are not used that often in the beginning. All right, but that's it. What you need to submit is a copy of your check results, which right there shows that I got 100%. All right, a copy of your PKA file, and then in this case, a copy of your Word document with all the answers to the questions. And what I'll do to make it easier, I'll go through all the questions. I'll put in red text. You know, I'll put the word answer in bold, so you know where to put them in there. That makes it easier for you guys, and also easier for me to grade. All right, thanks for watching.